If you've ever tried to work with a huge amount of data in Python, you've probably hit a wall and wondered, why is this so slow? Well, the answer to making it fast, the real engine behind pretty much all of modern data science and AI, is a library called NumPy. So today we're going to pull back the curtain and see what it is and why it's so incredibly important.
But first, before we get to the solution, let's talk about the problem, right? Python is famous for being super easy to learn and use. But the moment you throw millions or even billions of data points at it, it can grind to a screeching halt. So what's the deal? Why is it so slow with big data?
So let's really dig into this problem. Before NumPy came along, data scientists were kind of stuck. They had this amazing, user-friendly language, Python, but it just wasn't built for the kind of heavy-duty number crunching that real scientific research and big data analysis demands.
To make this super clear, let's just imagine for a second. You're a climate scientist, and your job is to find the average temperature across 1 million cities around the globe. That is a ton of data. How would you even begin to do that using just regular, plain vanilla Python?
Well, the old way involved using standard Python lists. And oh man, it was a slog. You'd have to create this giant list, then write a for loop to go through every single one of those million temperatures, one by one. You'd add it to a total, then move to the next, and the next, and finally, after all that, you could divide. With 100 numbers, fine. With a million, it's just painfully slow.
And this is where the hero of our story comes in. To solve this exact problem, this bottleneck of speed and scale, NumPy was born. So picture this, it's back in 2005, and a developer named Travis Elephant sees everyone struggling with this exact issue. So he sets out with a really clear goal: make number crunching in Python insanely fast by completely eliminating the need for those slow, clunky loops that process data one item at a time.
And this right here is the beautiful result. Remember that clunky four-step process we just talked about? All that looping? With NumPy, it becomes this. One single, clean, elegant line of code. That's it. It does the exact same thing, but it does it almost instantly. That is the power we're talking about.
So how? How does it do this? What's the magic trick here? Well, it all comes down to one fundamental concept: a very special data structure called an array.
You see, NumPy, which is short for numerical Python, has this secret weapon called an array. Now, a normal Python list is super flexible. It's like a junk drawer. You can throw anything in there. But a NumPy array, it's like a perfectly organized grid built for one thing and one thing only: numbers. And that specialization is what makes it so mind-bogglingly fast and efficient.
This slide really lays it all out, doesn't it? A Python list gives you flexibility, but you pay for it with slow speeds and high memory usage. A NumPy array says, nope, just give me the numbers. And in exchange for that focus, you get incredible speed, way better memory efficiency, and the ability to do math on the entire dataset all at once. No loops required.
And when we say faster, we are not talking about a small improvement. We're talking about being anywhere from 50 to 100 times faster than doing the same math with regular Python lists. That's not just an upgrade, that is a complete game changer.
Honestly, here's the best way to think about it. NumPy is like a turbocharged calculator that can perform an operation on millions of numbers all at the exact same time. Instead of adding them one by one, it just does the whole thing in one lightning-fast shot.
Okay, so this is way more than just a theoretical speed boost for programmers. This incredible power is the reason NumPy has had such a massive, real-world impact on the technology that we all use every single day.
NumPy isn't just a tool. It is the foundational building block for almost every data-heavy field you can think of. Data science runs on NumPy. Machine learning and AI frameworks like TensorFlow and PyTorch, yep, built on top of NumPy. Financial analysis, medical research like DNA sequencing, even image processing in tools like Photoshop, they all have NumPy running under the hood.
And it's not just for small projects or academic research. The biggest tech companies on the planet, we're talking Google, Meta, you name it, they all rely on NumPy's speed and efficiency to power their massive data analysis and machine learning systems.
And all of this brings us to our final and maybe the most important takeaway for you. If you have any interest at all in a career in data, AI, or anything like it, NumPy is square one.
And let me be perfectly clear about this. Learning NumPy is not optional. It's not a nice-to-have. It is the absolute, non-negotiable first step. It's the fundamental language you need to speak to work with data in Python, period.
And the absolute best part? It's so easy to get started. It's not some exclusive, complicated tool. Getting this power on your own machine is as simple as opening up a terminal and typing this one little command. You can be up and running in literally seconds. So, there you have it. We've seen how NumPy took Python from being a bit slow with data to being an absolute powerhouse. It's the silent, supercharged engine behind so much of our modern world. So the only question left is, now that you know its power, what problems are you going to solve with it?